Hello everyone, in this video I would like to introduce vectors in the context of linear algebra. The term vector appears in many different mathematical and physical contexts. For us, at least for now, a vector will refer to just an ordered list of numbers. So first, a matrix with only one column we will call a column vector. For example, this is a column vector, an ordered list of numbers. Here is another example of a column vector. We can add together two vectors in the most natural way possible, which would be just to add them term by term. When you add two vectors together, you get another vector of the same size. You can also consider the scalar multiplication of a vector. If A is just a scalar number, then we can multiply term by term to get something like this. So for a more concrete example, 2 times the vector u will give us the vector 2, 4, 6, which is actually just v. And if you notice 3, 6, 9 is just 3 times 1, 2, 3. This is 3u, but this is compatible with the vector addition. U plus 2u is 3u. Now, a linear combination of vectors is when we combine vector addition and scalar multiplication all at once. Given vectors v1 to vn and scalars c1 to cn, a linear combination of the vectors v1 to vn with weights c1 to cn is simply multiplying the scalar c1 to the vector v1 plus multiplying the scalar c2 to the vector v2, etc., all the way to cn times vn. The point of introducing linear combinations is so that we can pose a linear system of equations as a vector equation as follows. Suppose we have a system of linear equations like this. We can convert this into a vector equation like this. Here x1, x2, x3 are scalars. And we pose this as a linear combination of these column vectors with the weights x1, x2, x3. And solving for solutions to this linear system of equations is solving for the weights to this vector equation. In the next video, we will talk about how this relates to matrix equations.